Hello Math 13-16 students. Let's begin Lesson 3, Trigonometry of Arbitrary Angles. Previously in Lesson 2, we studied the trigonometry of obtuse angles. Excuse me, I said it backward. Previously, we did trigonometry of acute angles. Now, we're going to do trigonometry of obtuse angles and beyond. I said it backward, sorry about that. And every acute angle can be inscribed into a right triangle. So the trigonometry of acute angles is basically the trigonometry of right triangle. As you can see, any angle can be inscribed as a part of the right triangle. And that right triangle can be strategically positioned like this. The angle in question is always at the origin, and the right angle is always at the x-axis. Remember that? And then, thanks to Pythagorean theorem, we have x squared plus y squared equals r squared. And then from here, we can define trig ratios, sine, cosine, and tangent, as usual, the way you have been doing for high school geometry classes. Opposite of hypotenuse, adjacent of hypotenuse, and opposite of adjacent. These descriptions stay valid for any right triangle, no matter how it is positioned. But if it is positioned like this strategically, then that allows us to re-express these like these. Sine as vertical over radius, cosine as horizontal over radius, and tangent as vertical over horizontal. Now, this way, we can expand this idea further beyond the acute angle into obtuse angle, and then even beyond, even negative angles. How do we do that? Alright, this time let's not worry too much about the triangles. We just begin with a circle. Circle centered at the origin with radius r, and let's consider arbitrary angle. In this case, we got an angle that is greater than 180 degrees but less than 270 degrees. In radian measure, greater than pi, less than 3 pi over 2. So we got this coterminal point, the terminal point of this angle measurement in the third quadrant, like this. And this program is randomized, so you can run it again, and we may have some different places. This time in the second quadrant, this time in the first quadrant, fourth quadrant, etc., etc. Okay, alright. And then, no matter what the quadrant we are in, we can define sine, cosine, and tangent as y over r, vertical over radius, cosine as x over r, horizontal over radius, and tangent as y over x, vertical over horizontal. Oh, by the way, let me expand the font so that you can read these definitions better. It's easier to read this way. I should have done that earlier. And then cosecant, secant, and cotangent are just reciprocals. One over sine, one over cosine, and one over tangent respectively. So these three are not very important as far as the geometry is concerned. The reciprocal identities, these follow immediately from the definition. Cosecant is r over y, sine is y over r, so cosecant is 1 over sine is 1 over cosecant. Same for secant versus cosine, and then cotangent versus tangent. Okay, alright. Enough of all these. Now, shall we solidify our understanding through some example problem? Okay, let's go ahead and do that. Before an example, let's take one more preparatory step. Just one more. Signs of trigonometric ratios. A smart trig class. What do you mean by that? It turns out in the first quadrant, all positive. Sine, cosine, tangent, all positive. In the second quadrant, sine is positive, but cosine and tangent are negative. Third quadrant, tangent is positive, yet the other two, sine and cosine, are negative. And finally, in the fourth quadrant, cosine is positive, but sine and tangent are negative. So we have all positive, sine is positive, tangent is positive, cosine is positive, form this, a smart trig class. Remember this. All smart students in my class must remember this. A smart trig class. Why is that? Well, in the first quadrant, there's nothing much to think. Y over r, x over r, y over x, they're all positive because x and y are both positive. Now, in the second quadrant, in this case here, y over r is positive because y vertical is going up. That's positive. X, on the other hand, going to the left, that's negative. Now, if you go to the third quadrant, I should have stopped the playback. Okay, third quadrant here. In this case, tangent is positive. Both x and y are negative. So negative over negative. So tangent is positive. Sine and cosine are negative because y over r, x over r, y and x are both negative. Radius r is always positive. So in third quadrant, tangent is positive. The other two are negative. And then in fourth quadrant, cosine is positive, x over r is positive, y is negative there because vertically we are moving down, right? Y is negative. So here's the conclusion, a smart trig class. Okay, all right. We went through the definition and then we went through the sign of all trig ratios. Okay, let's use these to do some example problems. Here are very, very typical example problems. Cosine of theta is 5/7 and tangent of theta is negative. Find out all other trig values, sine, cosine, tangent, cosecant, secant, and cotangent. Okay, all right. Cosine of theta is 5/7. And then that is x over r. Okay, all right. Can I assume x is 5 and r is 7? Can I do that? Well, it turns out, yes, you can do that. Yeah. How about y? You're gonna need some work. How about this one here? Cosecant is 9/4 and secant is negative. Cosecant is 9/4, so you can immediately rewrite as sine of theta is 4/9. And that is y over r. So from there, you can determine y and r value. And then what's x? Well, using Pythagorean, you can figure those out. And one way to do that is to use Pythagorean to figure these x and y values, just the size, and then figure out pluses or minuses later. Let's see. What am I talking about? Let's draw a triangle, completely forgetting about the orientation. Let's do this one first. Okay, in this case, we are going to get something like this. So right triangle like this, radius is 7, and then vertical is 5. This picture is wildly wrong, but it's okay. Nobody cares about the scaling here. And then this is a quantity you have to figure out using the Pythagorean. Oh, excuse me. I did it right. Cosine is 5/7, so this is 5. And this is unknown. And then we can figure it out by Pythagorean. And then later, you can figure out pluses and minuses. You can do that if you want to. Same thing here as well. If you prefer to do it this way, I'm not going to stop you. But that's not my personal favorite. My favorite is to figure out a quadrant so that I place this triangle in right quadrant so that I can figure out the sign at the same time. So how does that work? Cosine is 5/7, so that's positive. And tangent is negative. So cosine is positive, so either it's going to be 1 or 4. A smart trick class, right? Cosine is positive. 1 or positive, but tangent is negative, so it's not 1, it's quadrant 4. So in the quadrant 4, we have to draw a triangle, so it's not going to be this kind of picture. But in fourth quadrant, we draw a picture, it's going to be this kind of triangle. Angle in question is always at the origin, and then right angle is the x-axis, and hypotenuse is 7, horizontal is 5, and then vertical, well, same Pythagorean computation as before, but you can clearly see this time this y-coordinate is negative. So I like this one a little bit better. It's okay to do it this way, and then get all those trig ratios without a sign, and then figure out the sign pluses and minus way later, a smart trick class. You can do that. But I prefer to do it this way. And my explanation in both answer keys here are based upon this method, so I'll follow that. How do I get out of this drawing mode? Ooh. Okay, let's go back to the first problem. Determine the quadrant. Cosine is positive, tangent is negative. Therefore, we have to have fourth quadrant. Cosine is positive, either 1 or 4. Tangent is negative, so it has to be 4. So draw a triangle, it's going to be like this. 7, 5, and this one you can figure out through Pythagorean. It's easy. You can do it like this. 7 squared minus 5 squared, so square root of 24, and that's negative. We're going down. Therefore, all trig ratios follow like this. We got everything done, including pluses and minuses. One more time? Alright, let's go to the next problem. Cosecant is 9/4, so sine is 4/9, that's positive. Secant is negative, therefore cosine is negative. Sine is positive, so either 1 or 2. Cosine is negative, so it has to be second quadrant. So it's in the second quadrant. And draw the picture in the second quadrant. And then use Pythagorean to figure out the horizontal x. Square root of 65, 81 minus 16, alright? And that's negative square root of 65 because I'm moving to the left. And therefore, I get all the trig ratios like this. I can do pluses and minuses at the same time. This is my favorite way. But if you prefer to get all those absolute values and figure out pluses and minuses later, go ahead and do that. I'm not going to stop you. That's a legitimate way too.